defines the access time of the memory. That is the speed of the memory. What is accessing the memory? You can read the data in the memory or you can write the data in the memory. Okay. So how fastly you can perform this read and write operation. So based on that, the speed of the memory will be defined. Okay. So this is what we discussed during the last lecture. And then we have another variety of, in a hierarchy, that we have another memory which is called hard disk, also called a magnetic disk. Okay, hard disk. We will call this as usually HDD, hard disk drive, HDD, capital letter. Okay. So this hard disk drive is a magnetic device, but it is a mechanical device. Okay. The another reason for this, the memory, this particular secondary memory is very slow in access time when comparing with other memories. The reason is, of course, it has a large capacity and also it is a mechanical device. Okay. What is mechanical device? There is a kinetic energy. Through the kinetic energy, it will work. That means through the movement, the parts. Moving the parts, it should work. Okay. By moving the parts, it should work. Okay. If you want to read, something should be moved from one place to another place. Okay. Some part. So that will take time as it is as it is a mechanical device. So that is also the reason for slow access time, very less access time of this device. Another one, of course, the capacity is high. So to search the record will take more time. Okay. This is very slow memory, but at the same time, you can permanently store a large amount of data in it. Not like RAM, you can store very less data, but that data also, if the power went off, you will lose the data. It will not be saved permanently. That problem will not be there here. But at the same time, it is very slow. Okay. So how the hard disk will be in your system? The hard disk consists of, it will not be single disk like your CD disk, no? It will not be a single disk. The disk, hard disk, consists of more number of metal platers. These each and every device, there are more number of disks, no? So these disks togetherly called platers. Okay. In the in this hard disk, we will not, hard disk drive, we will not call disk as a disk. We will call this as a platers. Okay, PLATTERS, platers. So disk consists of, disk means you can imagine HDD, hard disk drive. Hard disk drive consists of more number of metal platers. Okay. But these platers are rotatable platers. Rotatable platers, all these platers. Okay. These are rotatable platers. The speed of the rotation will vary this to the HDD to HDD. For example, some of the HDD will rotate in the speed of 5,400 rotations per minute. 5,400 rotations per minute. Generally, we will call that as a RPM. RPM. 5,400 RPM means what? RPM. Rotations per minute. Okay. So 5,400 rotations per minute. Some of the HDD will have the rotations as 7,200 rotations per minute. Some may have 10,800 rotations per minute. So that differs. Okay. So what's the first point we discussed? The HDD, which is hard disk drive, consists of more number of metal platers. Okay. That metal platers rotate at the speed of 5,400 RPM or 7,000 200 RPM or 10,800 RPM. Okay. There is a mechanical arm. Okay. So this is a read-write arm. Okay. Even here also we have arm. In the arm only all the disks will be inserted. Okay. But this arm will not move. Only the disks will, the platers will move. Okay. Here we have another arm which is called read-write arm. Okay. In this read-write arm, the read and write head, these are called read-write heads. These are called read-write heads, which can touch the disk. Okay, which can touch the disk. So these are called read-write heads. So the read-write heads will be attached with the read-write arm. Read-write arm. Okay. So this is a mechanical component in the HDD. The information, sorry, students, sorry.
Just kidding you.
Okay, so this is the read-write arm. These are read-write heads, read-write head. Okay, they should be called read-write head. This is called read-write arm. Okay, so here there is an arm that's called a spindle. About the track we will see. All these are called platers. Okay, the information will be written on the platers. Okay, information is written on the disk, but how it will be written? It will be written in a series of concentric circle. Here they have shown only one circle. Okay, so in the next layer again another concentric circle like this, and then again another circle. So the entire disk will be filled with circles like this. Okay, now just ignore this lines in between the circle. Okay, you imagine only the circles are there. So these if you look at the disk, or if you look at the plater, it will have series of concentric circles. Okay, now the series of concentric circles are called tracks. Okay, here they have shown only one track. This one circle only they have shown. No, that is called a track. Okay, one track. Like this, the disk full of tracks will be there. Okay. So what is this concentric circle on the plater is called track. T-R-A-C-K, track. Remember. The track will be divided into like this small segments. Okay, so here they have shown only one track, and they have shown how that single track is divided into small segments. Okay, now these segments should be called sector. Okay, so this is one sector, this is another sector, like this it will be the track. Every track will be splitted into sector. Remember. Okay, so and these three terms you have to remember: track, sector, cylinder. Okay, what is cylinder? At any point of time, if the arm position, the read-write heads arm position will be there in one particular track. For example, assume that now this is there in which track? We assume that this is in track number 2. Read-write head is currently touching what? Track number 2. And in the next disk also read-write head at that same time it will touch the track number 2 only. And here also track number 2. Okay, please understand. So at any point of time, if you look at the read-write arm, that will point a same track in each and every disk or each and every plater. Okay, at any point of time. Okay. So when you look at it, will not be like now this read write head is positioning track 1. Here this will position track 5. This will position track 18. It will not be like that. Okay. At any point of time, if you look at the um, uh, disks, all the disks, the read write head will point the same track number in each and every disk. Okay. Number of tracks in each platter will be same. That means the disk size is same, simply. But number of sectors will differ. See, because when you draw here, this circle, the surface of this circle is less than the outer circle, isn't it? So when you split the outer circle, for example, outermost circle, when you split into sectors, you will get more sectors. Okay. But that will differ disk to disk. Even some of the disks, no, inside how many number of innermost circle, may concentric circle, that means tracks, may how many number of sectors are there. The same number of sectors the outermost track will also have. This is one kind of architecture. Okay. Then what will be the meaning here? Here the sector size is small and the outermost layer may the sector size will be, each and every sector size space will be more. But number of sectors will be same. This is one kind of architecture. Now, but nowadays the outermost layer circle, this sectors are more in number when comparing with innermost track. Okay. So what is cylinder? See, now assume that all the read-write heads of the platters are pointing a one particular track 10. Okay. So here also track 10, here also track 10, here also track 10. So if you draw a line, you will get a cylinder shape. Okay. So that is called a cylinder. So at any point of time, the read-write head points a particular track will form what? A cylinder. Okay.
Hello, ma'am.
Yes.
Ma'am, can you record the lecture?
More than the 70% students are there or what? Only 58 are there. You couldn't
Ma'am,
understand or I have to repeat, you can tell.
ma'am, actually, I have network issues today.
Okay. So
So
you couldn't hear. So you couldn't hear clearly.
No, ma'am, I am unable to see the screen only, ma'am.
Okay. So PPT you couldn't see.
Yes, ma'am. And also, I'm automatically getting disconnected from the meeting, ma'am.
Okay. Okay.
That's showing.
Okay. 1 second. One second. Why meeting recording option is disabled? Okay, 1 second. Students, I think the previous lecture, no, before this, I took lecture for TY. For them, I started the recording. I think I did not close the recording. 1 second, students. I will leave from the meeting. I will rejoin them. Okay. 1 second.
Thank you, ma'am.
Okay, now I can start record. Okay. Yes, it is start.
Ma'am.
Yes, Hemakshi, you called me.
Ma'am, can you explain the read write ahead again?
Yes, yes, I will explain. I will. Okay. Students, this is called HDD. Okay. Hard disk drive. It's a secondary storage device. Okay. This has a number of disks which are togetherly called platers. Okay. Generally, it will have more than one number of disks. Okay. So that we can store more amount of data. Okay. This will have read write arm. Okay. With the read write arm, read write head will be connected. Read write head will be connected. Okay. This here, the disk will rotate in particular speed. For example, 5,400 rotations per minute or 10,800 rotations per minute or 7,200 rotations per minute. Okay. This is a magnetic device, but it is a mechanical device. So that is also one of the reasons the device is very slow. Okay, so the access time of the HDD is very less. Okay, sorry, very large. When access time is very high, then only what the device will be slow. Remember, okay, it is very slow device. That means access time is more. Okay, you should not write less. Okay. You know what is track? Each and every disk is splitted into a number of concentric circles. The concentric circles are called tracks. Okay. In this diagram, they have shown only one circle. Okay. Actually, like this, the entire disk will be filled with the concentric circles. Okay. So those circles are called tracks. Okay. If you look at each track, it is further splitted into sectors. Okay. In some of the architecture, all the tracks will have same number of sectors. Okay. All the tracks are circles. Remember, all the tracks will have same number of. Okay, not space. I'm talking about the space of the circles. I'm talking about, of course, when you compare space, the inner concentric circle will have less space than the outer concentric circle. Okay. But when we are talking about a number of sectors, this small segments, no. So if you count the total number of sectors in the inner track and also the outer track, in some of the architecture, both the number will differ. Some of the architecture, both will be same. Okay. That is one thing. Generally, the size of the sector, that means is one segment. Size of the segment will be typically 512 bytes per sector. Okay, so single sector will be 512 bytes approximately. Okay, so this is not the case in all the disks, but you should know at least approximately how much space the single sector will occupy. Okay, so sector will have approximately 512 bytes. Okay. Now, if any point of time, if you look at all the read write heads, it will be point the same number of track. I did not say sector, same number of track. Okay. So, so if you assume that right now, this all the read-write heads are pointing sector number 10, then that will form a cylinder. Okay. So that is called a cylinder actually. So if any point of time, see, when I say track, that will specify a track in a single plater. Okay. But when I'm saying cylinder, then that will denote a particular track position of read-write head in all the disks. That's why there are two different terms. You may wonder why unnecessarily cylinder is there, because cylinder is necessary to say that all the read-write head in all the disks are in same track. To denote that, we called that particular shape is called a cylinder. Okay. Okay. So if you want to read the data or write the data, what you have to do? See, in the next diagram, the cylinder is, see here. Each and every disk is splitted into what? Tracks. I did not show the sector here, okay, because each circle is not further divided into segments. Okay, I have shown only the concentric circles because to show what is cylinder. Okay, so now this is the point, midpoint. Okay, that's why we are calling this circles are concentric. That means keeping one as a midpoint, that will be drawn. This tracks will be drawn. That's why those circles are called concentric circles. Okay. These are platers. How many platers are there? 3 platers. Okay. Now you can see what is cylinder. See, if I take this, now assume that read-write head is there in this track. Okay. So if you draw here and here also a solid line, that will form one cylinder. Okay. This will form one cylinder. See my pointer? This is a one cylinder. This is one cylinder. Okay. Which is the next cylinder? See, go to next track. This is the next cylinder. Okay. And next, again, one more track, outer track, if you go, that will form another cylinder. Okay. Okay. Now, you have to know what is, of course, read and write will be done by read-write head. Okay. What is read? Already stored data will be retrieved. That process is called read. Okay. We already stored some data. Storing data means what, students? See, these are magnetic surface. Okay. So if you magnetize one particular sector, one particular cell, we can say, because sector will have more number of cells, remember. Okay. So if you magnetize one cell, which is nothing but you can magnetize using north pole or south pole. Okay. For example, you assume that upward arrow and a downward arrow. Downward arrow denotes a bit 0, upward arrow denotes bit 1. Okay. So you can magnetize. If you magnetize this particular cell, which means you wrote some data in this cell. Okay. You wrote. Data means what? Either 0 or 1. That only you can write, no? 0 or 1. But you will not write one number, how you will write in a paper. Like that you will not write. There are some symbol. For example, upward arrow. It is polarized, magnetized north or magnetized south. Okay. So magnetized north, for example, denote 1. Magnetized south denote 0. Like that. Okay. If you look at some of the sectors will not be magnetized only. Those sectors are what? Those sectors are empty. So you can write something. Okay. So like that, the read-write process will be. Okay. On the magnetized surface, in the cell, the magnetic energy will be passed. Okay. Through that, writing will happen. If you want to read, again, you have to pass the energy to retrieve the data. For example, here I load 1, I wrote 1 or 0. That if you want to read, if you want to take using read write head, that is called a reading. Writing means putting the data, writing the data inside the disk. Reading means taking the data which already you wrote inside the disk. That is called reading. To read, you must have already written. Okay, then only you can read. Okay, now suppose one particular sector data I want to read. Okay, so currently the read write head will be in some position. For example, I want to read some data in track number 12. Okay, but current position of read write head is track number 18. Okay, I want to read the data from, assume the track number 10, but currently it is in track number 18. Okay, so when I want to read or write, I have to first position the read write head in an appropriate place. Okay, where I have to position, I have to first move the read write head to the appropriate track. Which track? Track number 10. Currently where it is? Track number 18. Okay, so I have to move the read write head. Okay, first to position the appropriate track. Okay, first I will position appropriate track and then I have to position appropriate sector. Okay, remember. So positioning the read write head in an appropriate track is called seek time. Is called seek time. Okay, so what is seek time? Currently the read write head is in some position. Why it is in some other position? Because the previous read or write would have happened in that sector number 18. That's why currently the read write head is in position number, track number 18. But in the next request where you have to go to track number 10. So how the movement, so that time is there, no, to properly keep the, before reading or writing, properly keep the read write head in appropriate track. That is called a seek time. Okay, so the time taken, what is seek time? The time taken to position the read write head in appropriate track before reading or writing the data is called seek time. Okay, the time is called seek time. Okay, a rotation delay, we have another time delay, that is called rotation delay. After you kept the read write head in appropriate track, you have to next position the read write head in an appropriate sector from where you want to read or write. Okay, so for that again you have to move, that time read write head will not be moved. That time the disk will be rotated. Okay, the disk will be rotated. Through rotating the disk you can position the appropriate sector. Okay, through moving the read write head you can position the appropriate track. Remember, if you imagine, this is very easy. Wait, let me finish and then I show in the next diagram how the movement of the read write head will be and how the rotation of the disk would be. Okay, so but here you have to remember, you have to understand what is seek time and what is rotational latency. Seek time is a time to keep the read write head in appropriate track before reading or writing process. That's called a seek time. What is rotational latency? After kept the read write head in appropriate track, okay, to read or write we have to move to the appropriate sector. Okay, so for that the disk will be rotated. Okay, so how much time it is taking to position the read write head in a particular sector, that is called rotational delay or rotational latency. Rotational latency. Okay, The seek time and rotational time are not actually read time and write time. These are extra times, no? So we have to know about this. So the seek time should be less, rotational latency also should be less. That is the preferable one, right? Then only quickly you can retrieve the data. Now, see, seek time. So now this read write head, how it can move? It can move backward, forward. Back and forward, backward and forward only it can move. Okay, it can move only back and forth. Always remember. Okay. So now assume that it is in sector number, track number 10. If you just a little move this side, you may come to what? Sector number 20. Okay, again if you move, you can come to sector number 30. Again, if you move, you may come to sector number 31, 32, 33, 34. But how you are moving backward? Again, suppose assume that you are in track number 20. You have to move to track number 10. How you have to move? Again, forward. You have to move forward. Okay. So the read write head will move back and forth only. Okay. Essay like back and forth. Okay. Like this it will move. Okay. But how the disk will move? Disk will not move back and forth. Okay. Disk will rotate. Okay. Left and right. So through rotating, you can point the sector. Through moving the read write head back and forth, you can point the track. Getting it? This is the track 1. If you want to go to next track, how you have to move this? You have to move this little behind. Okay. So back and forth you will move this. Okay. But the disk will move, disk will rotate. So through rotation, you can access the disk content left or right. Okay. So through rotating the disk, you can position the appropriate sector. Through moving the read write head, you can position appropriate track. Is this clear? Students, is this clear?
Yes, ma'am.
Okay. Now, how exactly the read write will happen? I just play a video.
Ma'am, it's not audible.
It's not audible.
No, ma'am.
No, ma'am.
I shared with the Students, wait, I'm going to play. Okay.
You may already know that
Oh, sorry.
the data stored in details.
54. Wait. Mute.
Ma'am, now it's audible.
An object can be magnetized with the north or south pole or either end. You may already know that the data stored in computer as a series of ones and zeros, which is a machine language commonly known as binary code. But how can we represent a 1 and a 0 magnetically? So, let's check the next part. A bit is the smallest unit of data storage. It can be visualized as a many scale blocks that can be magnetized into a permanent magnet. Every red, blue, or gray block in this picture is a bit. The red blocks have north poles facing up, and the blue blocks have north poles facing down. These are with the computer recognizes as 1 and 0. Gray blocks are the empty bits that are not yet been magnetized. The read-write head assembly has two separate heads: the red head and the write head. The write head is basically an electromagnet with a coil property shaped like this. To direct the magnetic field into a bit, it magnetizes it as it passes by. It can magnetize a bit as a north facing up or a north facing down simply by changing the direction of the current in the coil. As you may remember, reserving the direction of current in an electromagnet results a reverse in the direction of the magnetic field. Now, let's check the writing process by the write head of the read-write head assembly. Please try to visualize that the direction of the magnetic field and the direction of the current against the writing ones and zeros. Therefore, I guess, you have understood the process of writing by the write head. Next, reading process. Once written, the bits can be read by the read head, which senses the direction of the magnetic field as it goes over the written bit. Now, let's check the reading process by the read head of the read-write head assembly. Therefore, I guess, you have understood, the process of reading, by the read head. A hard drive, as a whole, looks like this.
Okay, students. So read and write operation, how it will be done in the HDD. Okay, that's what the video. Okay, about the structure I said you. Okay, so we no need to see that. Okay. Students, today I have a FDP program, so I can take one lecture only, or otherwise the second lecture I have to schedule after 5:30. Okay, so
Ma'am, at that time, batch
we
2
have
has NSM
okay,
practicals.
I will not. Okay. So today only one lecture. Okay.
Ma'am, I had a
So,
doubt.
yes.
Ma'am, structure of hard disk are all same for all type of hard disk, or is there a difference
No,
in
no,
old
it will
hard disk
differ.
as well
It will
and new
differ.
one?
It will differ because now current laptop, no, we have SDD, not HDD. Okay,
Yes, ma'am,
solid
SSD.
state.
Yeah.
So solid
No, ma'am,
SSD, solid state.
I,
You are asking
I'm
about
asking that
only
all
HDD.
kind HDD. Yes, ma'am.
HDD almost yes, process, working, everything is same only. Because any HDD, if you take disadvantages, it is a mechanical device. Okay.
So if it is
Yes,
a
ma'am.
mechanical device, then it is a slower one. It's a slower device. Okay.
Yes, ma'am.
So, so all the HDD, the working reading and writing process, HDD, only HDD. There are many varieties of disks. So in HDD, reading and writing process will be same. Even the structure also same. If you look at the disk, it will have tracks, and inside the track sector will be there. The difference will be how much data you can store in each and every sector. Okay, so that will be the major difference. That's it. And another one, I don't know, you noticed or not, when we read the data, no, look at here, how the data will be stored. See, you should not think that, can you see the PPT?
No, ma'am.
One second. Oh, I have to. See how the data will be stored in which sequence. Randomly only it will be stored. Remember, see, for example, here assume that in this sector there is a data. Okay, continuation of this data will be stored not nearby sector. Okay, it will be stored again in another disk may the same sector. Okay, so continuation of this data block will be stored again here. So that also you should know. That's why the read write, that's why we are calling it as accessing in the cylinder format. Okay, so when you want to, for example, there is a chunk of data. Okay, so that chunk of data, all the data bits inside the chunk is related. Okay, so the entire chunk, assume that you can't store in a single sector. So how it will be stored? It will be stored in this sector. Okay, and then again the continuation of this will be stored in the next sector. That means in this sector, in the same cylinder of the next disk, continuation of this will be stored in again the same sector in the next disk. Okay, so the data will not be stored, related data will not be stored contiguously. Okay, it's not continuous, contiguously will not be stored, randomly it will be stored. Remember. Okay, that is another one. Okay, that's it. I finished the lecture. So in the next lecture, we will see about the input-output devices. That is also one of the part in the hardware review. Okay, not only memory device, we have to discuss about the input-output devices also. That we will see in the next lecture. And remember, again and again, I will not repeat. Every day, whatever I'm teaching should be noted by you, and it should be, you have to go through that at the end of the day. Just before ending the day, you have to go through that. Okay. Okay. Thank you, students.
Yes,
You
ma'am.
all can leave.
Thank you, ma'am. Bye, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Bye, ma'am.
Bye. Bye, students. Bye.